Welcome to Module 2 of the SRE Practitioners course. So Module 2 is all about service level objectives and emphasizes the idea that SLOs are really the key element that SREs manage to, and in particular to ensure that clients and customers are happy. So the SLOs are intended to help manage that. The syllabus for this module. First of all, we'll talk about how SLOs have evolved in terms of what is their focus these days, especially with large, complex distributed systems. The second point is identifying system boundaries and how the different boundaries between components of distributed systems are important for setting the service level indicators in order to determine whether or not you're meeting your SLOs and staying within your error budgets. And finally, the third point is how can you use error budgets to do things more than just controlling the speed and velocity of releases versus stability. There are many ways the SLOs and error budgets can be used to help with a variety of things. So let's get into it. Same as all the other modules in this class, there is a video. In this case, it'll be a deep dive on SLOs and SLIs. A case study by Kudos Engineering and Home Depot, 2 case stories. Some discussion around establishing SLOs in distributed systems, and an exercise around cloud service level agreement examples. This is just kind of a recap of some of the things we talked about in Module 1. So SLIs are really measurements, well, at least data that are necessary to determine whether or not you're meeting your SLOs. They're using the example here of availability, which is certainly the most popular kind of reliability indicator. So SLOs are goals we set for how much availability we expect from a system based on business requirements. Typically, this is driven by business requirements. Whatever the goal level you set needs to be compatible with your business goals. And SLA, service level agreements, are the legal contracts or part of your terms of service between you and your customers that explain what happens if your system doesn't meet its SLO. What are the penalties and so on? The fourth bullet here is SLO are usually objectives set between a client server boundary. For example, in an architecture, you'll have a lot of different boundaries if it's a distributed architecture. So you can have SLOs not only at the end customer boundary, but also at the different layers of the system and all the different boundaries. That's part of the challenge that SREs face, is to become competent and confident with how to determine where to set SLOs so you can produce meaningful information at the different levels that will add up to the service SLO customers are expecting. The point here, availability simply means that your service is available to consume. Again, this can be defined by your own organization, whatever you want it to be, but usually that's the way it's defined. Availability would be whether or not the system is available to do work when needed. It doesn't necessarily mean that when the system is working, that it's providing the right answer. So that's a different kind of SLO. That might be an error budget, or sorry, that might be an error count reliability, different kind of reliability, but availability is really just whether or not it's available at all to do the work. And again, the idea is just setting SLIs and SLOs at system boundaries. You don't just look at the top level customer interface to set SLOs typically, even though the ultimate goal is to satisfy the customer. The point is you may need to look deeper into your multi-layer distributed system in order to come up with the right SLOs and SLIs to monitor as an SRE. Okay. Again, just kind of a summary, differentiating what is SLOs, SLIs, SLAs. So in other words, an SLI, a service level indicator, is what should be true. It's the data that would indicate whether or not something is correct or not, and whether or not it's satisfying an SLO. Whereas the SLO gives you an idea of what portion of the time something needs to be correct, and the SLA kind of is a or else. In other words, is a contractual requirement, and all of these SLIs and SLOs are in service, if you like, in support of, in other words, the SLAs. So we're going to do a short activity. I'll explain the activity. The course is allocating 10 minutes. You can go, when after I explain it, you can turn off the video and do the activity on your own. Budget yourself at least 10 minutes. So the activity is really, you should think about how can you establish SLOs in distributed systems. There's a lot of possible SLOs and a lot of things you might want to do. It's not just a matter of pulling a number out of the air. You've got a lot of complexities. You may have some parts depending on other parts in the system in order to accomplish, let's say, availability. If one part fails, that could have a domino effect on other things. So what do you think you might do to establish SLOs? And then after this activity, we'll go through some examples, but I'll give you just some hints for the kinds of things that I do in my consulting work when I am faced with answering this kind of question with a client. It's certainly not just a matter of pulling SLOs out of the air. You want to think deeply about what is the customer's expectations. If you have a service, there may be multiple uses of that service, use cases, or customer journeys, some people might call it. So you may have SLOs for every one of those journeys. You may even have more than one. Let's take a simple example like a bank account on your phone. One of the journeys would be logging into the bank account. How often does that not work or work? Once you're into the bank account, are you getting accurate information? What percentage of the time maybe is the data a little out of date or maybe not even accurate? So there are many possibilities. Behind the scenes, there's not just your cell phone, of course, there's the network, there's the servers, and a lot of different services and operations going on behind the scenes within the bank. So what do you think? How would you go about determining SLOs for all of those things? So go offline for a few minutes, think about it for 10 minutes, write down some notes, and we'll come back and have some discussion about that in the next few slides. All right, assuming you did that, we'll carry on. So this is where, it makes you think a little bit about what do you do with SLOs? How have things changed in the context of distributed systems? In the, if you like, the bad old days when you had one system serving the client, maybe a monolith or a large mainframe with only one or two applications, it was a lot easier. But today you have many use cases being provided by distributed systems. So it can be complex. You may have a failure that's cascading. One part of the system fails that then causes something else to fail. How do you determine what the SLO would be in that context? That's something to think about. It may be difficult to determine the correct boundaries. So it does require that you have some understanding of your system architecture so that you understand how a failed component will affect other components. You may have to model the behavior of the system, or at least come up with a pretty clear idea of how the system is supposed to work and where the failures might occur. You may have a lot of dynamic activity going on, multiple parallel activities going on in a large system with a lot of traffic. You can have many use cases going on simultaneously. So how do you, pull out the particular SLOs for the particular activity that you're trying to build SLOs for? Emergent phenomena where you maybe have some new service or some new activities that you have to consider. Will your SLOs be reliable and stable enough to work, even though there are some changes that inevitably will happen in the system? Relationships are nonlinear. In other words, one problem can escalate to other parts of the system. It's not just about cascading failures. You may have one component that serves many other systems, and that may be an area where you need to have a closer look, closer monitoring, more SLOs or tighter SLOs. You also have to consider feedback loops. Wherever you have a need to get, let's say a client wants to see what's happening and you want to keep track of whether that's working. So make sure that you're putting SLOs on those feedback loops as well, and make sure that you have SLOs that keep track of how well those feedback loops are working. So the point is that, as it says in the blue box here, describing a system as complex is often not really helpful. It's kind of a point of resignation. It infers that the system can't be described, predicted, or managed. So yeah, these things are in fact, issues of complexity, but you can't resign yourself to saying, well, therefore we can't manage it. Of course you can, but it does require you to think carefully and thoroughly about the particular scenarios that are important to your clients. The real, focus needs to be on customer expectations. Again, availability being the primary type of reliability that SREs care about. Related to that is the quality of service once you get systems available. And once they are available, you care about the quality of the service being provided. So the SLOs, again, are targets for the associated with the data, the SLIs that are quantifiable measures. SLIs could be more than just availability. It could be things like average response time, or response time percentile, or throughput, peak and trough you might care about, database call counts and durations, domain name systems, DNS, and service secure sockets layer, SSL timings, document object models, processing and page rendering, mean time to detect. So there are many things. This is by no means an exhaustive list. I'm not even aware of such an exhaustive list, but as an SRE, you really do need to understand what is it that's important to your clients in your systems, and build up SLOs and SLIs for those things. So the right side here is just some examples. You may say that 95% of the 95th percentile of home page responses should be less than 200 milliseconds over 5 minutes. So that's a complex statement, but you may indeed need to define things carefully like this in order to satisfy your customers' expectations. Another one might be 95% of requests should be completed within 250 milliseconds over 24 hours. 95% of services should be available for 99.9% of time over 30 days. An SLO is between components in an architecture. So it can mean producing components and consuming components have to be considered, both sides, in order to come up with a complete view of the SLO. And you may have to have SLOs for each of those interfaces and then consolidate them into an overall SLO. Availability simply means that your service is available to consume. It does not mean that the consumers get the answers they expect when they expect them. So again, that's a repeat of the previous slide, but it is certainly an important point. Just because something's available doesn't mean it's satisfying customers. It may not have the quality of service a customer expects, even though it's available. So other types of SLOs than availability are typically very important. Setting SLOs and SLIs on system boundaries is a thing. Again, if you have a distributed system, you need to understand how the system interacts with the different parts of the system, which system boundaries are critical to your SLOs and SLIs, and what are you going to measure. Most services do not have an even distribution of transactions throughout the day. So you may even have some SLOs, SLIs that are specific to time of day. So there are many possible variables that you need to consider. And this is why, setting up SLOs and understanding how to do it is so important to an SRE.